Hi, my name is Bahadur Ahmedov. In this video, we're going to discuss the binomial formula. We're going to try to understand this and try to use this. So the question is, finding the square of a sum of the two numbers is always important for us. So we know the formula for finding the square of the a plus b, which is going to be a squared plus 2ab plus b in the square. Sometimes we might need to find a cube of the a plus b, and we know the formula as well. So this is like a cube plus 3a squared b plus 3a b squared plus b cubed. But what if I need to find any power of the a plus b? So I need to find the 10th power or 15th power or any other power of the a plus b. So in order to do this interviews, we need so-called binomial formula. So in general, a plus b in the power of n is going to be equal to the summation of k starting from 0 to the n, the combination of the n and k, a in the power of k, b in the power of n minus k. So this formula is called the binomial formula. So at the first glance, so this formula looks terribly difficult and long. So what we are going to do is we're going to try to understand every of its components. So we are going to first of all discuss about this sigma notation. We call this as a sigma notation. And then we're going to talk about how to calculate these combinations. And here inside these combinations, we need to calculate the factorials as well. And we're going to introduce the factorials and discuss the operations with the factorials as well. And the rest of the things is easy, which more straightforward, because we just need to find the powers of the A and powers of the B. Okay, so let's start with the sigma notation. So this is going to be the first topic which we are going to discuss first of all. So this is called the sigma notation because this is the capital sigma from the Greek. Or this is going to be a small sigma. This is the capital sigma. So this is the capital. This is the small sigma. Okay, so sometimes we need the summation of some terms, some sequence. For example, the summation of the 1 plus 2 plus 3 plus 4 plus and so on until, let's say, 50. Okay, so in order to save the space, people have figured out the notation. So they said, okay, so why I don't just write this as the summation of k, where k is going to start from 1 until 15. Okay, so what does it mean? So in the sigma notation, we have here these two parameters. So this parameter on the bottom is going to mean, so from which value of the k we need to start, until which value we need to continue. So until which and from which, or the initial or the terminal points. And between of these numbers, we are going to just increment the k. So basically for every step, what we're going to do is we're going to just add 1 to the previous value of the k. So how it works, so let's try to do this. So let's say I would like to find the summation of the k. Simply, k starts from 1 until 7, let's say. Okay, what does it mean? It means that I need to find the values of the k starting from 1 until 7. So what kind of values I have? So okay, here I have the values for the k. So I need to start from 1, 2, 3, 4, 5, 6, and 7. So basically by incrementing to the previous values by 1. Okay, so now here I need to write down the formula, so which is by coincidence just the k, but later on we're going to see the other values, other formulas. So for every value of this k, we need to calculate, let's make it k squared. Okay, so that it's going to be easier for us to distinguish the formula and the values for the k. So the formula here is going to be k in the square. So for every value of the k, which we have just listed, we need to calculate the value of the formula. So in this case, which is k squared. So it's going to be 1 in the square, 2 in the square, 3 in the square, 4 in the square, 5 in the square, 6 in the square, and 7 in the square, 49. So what we need to do at the end is we just need to sum all of these values of the formulas, which we've just calculated. So it's going to be the summation of the 1 plus 4 plus 9 plus 16 plus 25 plus 36 plus 49. So this is how it works. So again, so it's going to be, so this is going to be called as a sigma. So this is going to be the formula of the sigma. So which basically means that for every value of the k, we need to calculate the formula. So let's do a couple of more examples of calculating the or expanding the sigma notation. So let's say I'm going to calculate like a sigma of k starting from 1 until 6 of the k divided to the k square plus 1, let's say. And again, inside the sigma, we have the formula, and we need to evaluate this formula for every value of the k, starting from 1 to the 6. And again, one of the ways to understand this is to make the table. So the table for the values of the k. So the initial value of the k is 1, and the terminal is 6. And between of them, we just need to add 1 to the previous ones. So basically, we start from 1, 2, 3, 4, 5, and 6. So now for each of these values, we need to calculate the value for the formula. So formula in our case is k divided to the k squared plus 1. So basically, I need to substitute 1 to this formula. So in this case, it's going to be just 1 over 2, right? Then I need to substitute 2 to this formula. So in this case, it's going to be 2 divided to the 2 in the square plus 1, which is 5. Then we need to substitute 3, which is going to be 3 over 10. Then 4, it's going to be 4 over 17. Then 5, it's going to be 5 over 26. Then 6, it's going to be 6 divided to the 37. So we've calculated the values of the formula for every single value of the k between the 1 and 6. And at the end, we just need to sum them, right? So it's going to be a 1 over 2 plus 2 over 5 plus 3 over 10 plus 4 over 17 plus 5 over 26 plus 6 over 37 is equal to the sigma summation of the k starting from 1 until 6, k divided to the k squared plus 1. So you can see here that instead of writing all of this long terms, we can just write this in a more compact form, even though this is less understandable than the first two, right? Okay, so this is called the sigma notation, and this is widely used in mathematics, and it's as well in computer science. And whenever you do the programming, you will need this kind of operations. Okay, so if we need sigma in order to write the things in a compact form, so sometimes we need to create this kind of tables in order to expand the sigmas. Sometimes we need to have some experience in order to write down the big terms in the sigma notation. But so far, in order to calculate the binomial distribution or binomial formula, or just use this, we just need this table. So basically, if you are given a sigma formula, you just need to create the table and just sum all the values of the formula which you have just calculated in the table. So the second thing which we need to discuss is the factorials, or the combinatorial formula. So the combinations formula. So which basically tells you that C and K, so where N and K are two natural numbers, or non-negative integers, let's say, because they might be 0 as well. So where N is always bigger than K, so this is equal to, so basically N goes up to the numerator, N goes up to the numerator is going to be n factorials. So k goes down to the denominator, k factorials. And additionally, on the denominator, we're going to have the difference between n and k. Okay, so this is the formula. So now we are going to try to understand what is the factorial and do a couple of calculations. So please note that in this formula, k is always n is always bigger or equal to the k, always. So it can be negative, otherwise you need to calculate the negative factorial. So what's a factorial? So factorial of a non-negative integer n is equal to, so it's going to be denoted as n factorial is equal to the multiplication of all the numbers, starting all the natural numbers or all the integers starting from 1 until this n. So basically, if you need to calculate the 2 factorials, is going to be equal to the 1 times 2, so which is 2. So if you need to calculate the 5 factorials, what you need to do is you need to multiply the numbers starting from 1 until 5. It's going to be 1, 2, 3, 4, 5, which is going to be equal to the 6 times 20, which is 120. So in general, you should also know that 0 factorial is equal to the 1 by the definition. Of the factorials. Okay, so now when we know what is a factorial, let's do a couple of calculations of this combinatorics or combinations formula. So let's say if I need to calculate the C of 5, 2, okay, what I need to do is I need to write this down. So the 5 goes up, so 5 goes up, it's going to be 5 factorials. Then 2 goes down, it's going to be 2 factorials. And additionally to the 2 factorials, I need to multiply this to the 5 minus 2 factorials, which is 3 factorials. The 5 factorials divided to the 3 factorials multiplied to the 2 factorials. So it appears we don't need to always use a calculator in order to calculate all of these factorials and then divide them. So it appears most of the time in this formula of the combinations, so the factorials are going to be canceled most of the time. For example, so what means like a 5 factorials divided to the 3 factorials? So we can easily cancel lots of terms here, it appears, because 5 factorial means the multiplication of the numbers starting from 1 until 5, and 3 factorial means multiplication of the numbers from 1 to the 3, right? So you can see that we can cancel the 3 terms here, and the answer is going to be equal to the 3 times 4 times 5 only. So in general, for example, if you need to divide it 7 factorials to the, I don't know, 4 factorials, so this division is going to be equal to the 5, 6, 7, right? Because on the numerator, you have the numbers starting from 1 to the 7, and on the denominator, we have the numbers starting from 1 until 4, and we can cancel those terms. So this idea is really important because it helps us to simplify our calculations. So here we can basically cancel 5 factorials to the 3 factorials, and it's going to be simply 4 times 5, right? So let me write 1, 2, 3, 4, 5 divided to the 1, 2, 3 times 1, 2. Okay, so we can cancel this terms and this terms, and the rest is going to be 20 divided to the 2, which is equal to the 10. So now we basically have all the ingredients of the binomial formula. We know all the ingredients of the binomial formula and can try to calculate, can try to do some examples and exercises. So we know what is a sigma notation, right? So which means that I need to get the values for the k starting from 0 and increment this by 1 until n, okay? I know how to calculate the combinations. Okay, so for every value of the k, I need to calculate the combinations. Then we need to calculate all of these terms as well. So basically, if you remember, when we introduce the sigma notation, we say that, hey, there's going to be a formula which we need to calculate for every value of the k. And this formula for the binomial formula is going to be really huge. So we need to do lots of calculations for doing that. So let's try to use the binomial formula, first of all, to expand this term, for example, because we know the answer already. So let's start to do an example. So the first example is going to be a plus b in the cube. And I'm going to expand this using the binomial formula. So according to the binomial formula, it's going to be summation of k starting from 0 until 3 times in combinations of the 3 and k, a in the power of k, b in the power of 3 minus k. So what we're going to do is, I'm going to write down the values of the k starting 0, 1, 2, and 3. And for every value of the k, we need to calculate this formula. Okay? So when k is equal to the 0, it's going to be this combination of the 3, 0, a in the power of 0, b in the power of 3 minus 0, which is 3. So let's calculate the combinations of the 3, 0. It's going to be 3 goes up, 3 factorials, divided to the 0 factorials, multiplied to the difference between 3 and 0, which is again 3 factorials. So it's going to be a in the power of 0 is 1, and b in the power of 3 is b cubed. So we know that this is going to be simply 1, it's going to be simply b cubed. So let's calculate this. When k is equal to the 1, it's going to be c 3, 1. So basically, I'm just substituting this k here with the 1. So c 3, 1, a in the power of 1, b in the power of 3 minus 1, which is t. So it's going to be a combination. It's going to be 3 goes up, divided to the 1 goes down, and the factorial of their difference, which is t factorials. T factorials. So a1, b squared. So we know that the 3 factorials divided to the 2 factorials is equal to the 3, right? Because 3 is the multiplication of the 1, 2, 3. And if you divide this as a multiplication of the 1, 2, then there will be only 3 on the numerator. So basically here we have 1, 2, 3, and here we have 1 and 2. So these are going to be canceled, and you're going to have simply 3. So this is going to be 3a, b in the square. So when the k is equal to the 2, so I'm just going to substitute the value of the k to be equal to the 2 to here, here, and here. So this is going to be c 3, 2, a in the power of 2, b in the power of 1. It's going to be, again, 3 goes up, then 2 goes down, and we need to multiply this to the difference of this 3 and 2. It's going to be 1 factorial, right? So the a squared b1. We already know that the 3 factorials divided to the 2 factorials is equal to the 3. So it's going to be 3a squared b. And at the end, what we need to do is we need to just, we need to get this value of this 3 and substitute this to here instead of this k, this k, and this k. So it's going to be a combination of the 3 and 3, a in the power of 3, b in the power of 0. So let's do the calculations. It's going to be, so 3 factorials divided to the 3 factorials and multiplied to the factorial of their difference, which is 0 factorial, times a in the power of 3 and b in the power of 0 is going to be 1. So the answer is going to be simply a cube, because 3 factorials divided to the 3 factorials is simply equal to 1. So if you remember, for the sigma notation, what we need to do is we need to get all the values of the k starting from 0 until 3, calculate this formula for every value of the k. We did this, right, for all the 4 values. And at the end, we need to sum them. All of the calculations we did for every value of the k. So it's going to be b cubed plus 3ab squared plus 3a squared b plus a cubed, which is a plus b in the cube. So indeed, this is the same formula as we used to have in the beginning of the lecture. This is what we started from. So we can use this binomial formula for the higher pairs as well. So let's do one more exercise, one more example. example, where we need to open the brackets a plus b in the power of, let's say, 5. So according to the binomial formula, it's going to be the summation of k starting from 0 to the 5, a in the power, sorry, so it's going to be the combinations, c 5k, a in the power of k, b in the power of 5 minus k. So we are going to calculate this formula for all the values of the k starting from 0, 1, 2, 3, 4, and ending to the 5. So let's start this for the k is equal to the 0. So I'm going to do the calculations a little bit more faster because we understood some of the concepts before. It's going to be c 5, 0, a 0, b 5. So c 5, 0 is going to be always 1. So please note that whenever we have the combination of n 0, it's going to be simply 1, or a combination of the n and n is also going to be equal to the 1. This is really important because it makes your life much more easier. So you can calculate those things, you can know those things without any calculations. So it's going to be simply b in the power of 5. So when k is equal to the 1, it's going to be c 5, 1, a 1, b 4, right? Please note that the sum of the pairs of the a and b is always 5. So here it's 5, so here it's 5, and in all the other terms, it's also going to be equal to the 5. So it's going to be c1, 5, it's going to be 5 factorials divided to the 1 factorial multiplied to the 4 factorials, a1, b4, which is going to be simply 5, a1, b4. So when k is equal to the 2, it is going to be c5, 2, a2, b3. Again, the sum of the pairs of the a and b is equal to the 5. So the c5, 2 is 5 factorials divided to the 2 factorials and 3 factorials. We've just calculated this when we introduced the combinations formula, right? So it was equal to the 10. So, or we can do this one more time as well. So it's going to be a multiplication of the 1, 2, 3, 4, 5. So here we have 1, 2 times 1, 2, and 3. We can cancel these terms, and 20 over 2 is going to be 10. So a square b cubed, which is going to be 10 a square b cubed. So when k is equal to the 3, it's going to be c5, 3, a3, b2. So it's going to be 5 factorials divided to the 2 factorials and 3 factorials, a cube b squared, which is going to be 10 a cube b squared. Then when k is equal to the 4, it's going to be c5, 4, a4, b1. So it's going to be 5 factorials divided to the 4 factorials and 1 factorials. So a4, b1. So this is going to be simply, so we can cancel those terms more or less. It's going to be 5, right? Okay, so it's going to be 5 a4, b1. And at the end, when k is equal to the 5, it's going to be c5, 5, a5, b0, which is going to be simply a in the power of 5. So we've calculated this formula for all the values of the k starting from 0 until 5. And at the end, what we need to do is we need to sum them because this is the sigma, right? Summation. So we're going to sum everything. It's going to be so a plus b in the power of 5 is going to be b in the power of 5 plus 5 a b in the power of 4 plus 10 a squared b cubed plus 10 a cubed b squared plus 5 a4 b plus a in the power of 5. So, and this is how the binomial formula works. So in our next videos, we're going to discuss how to use the binomial formula in order to calculate the pairs of the polynomials.